We're going to begin by talking about problems that an entry-level network technician should escalate. The complexity of modern networking has made using a solid troubleshooting methodology a necessity, not an option. Networks can express problems and issues in many ways. This can lead to much frustration on the part of the network users and the technicians responsible for fixing problems. If such problems are not resolved quickly, they can lead to loss of revenue and productivity for an organization. There are a number of problems that should be escalated up the troubleshooting chain as soon as they're discovered in order for them to be resolved in the most expedient manner. The first of those problems is the switching loop. Users complain that the network works fine for a while and then goes down, and then works fine for a while and then goes down. This indicates a spanning tree protocol convergence issue or a switching loop. In either case, this is beyond the entry-level technician's capabilities and should be escalated as soon as possible. Then there's the broadcast storm. A failing NIC or application may cause a situation in which a broadcast storm is created. The NIC goes down, then comes back up, then goes back down, and it does this repeatedly. This is often referred to as a flapping NIC. Each time it comes up, it sends out a broadcast advertising its status, which creates traffic congestion. An application can do the same thing. In either case, escalate this up your support chain as soon as it's discovered. Similar to the switching loop is the routing loop, but it involves the routing process. This is more likely to occur when older routing protocols are used, but may also occur due to a misconfiguration of routers, as in there are multiple static routes to the same location. Often switching to a newer routing protocol like OSPF will resolve or banish routing loops, but this needs to occur farther up the support chain. There are other routing problems that, once discovered, should be moved up the chain. Routing problems can manifest themselves in many different ways, including missing IP routes, failure to discover neighboring devices, or failure to connect to neighboring devices once they're discovered. When routing problems are suspected, it is necessary to escalate the issue to the proper technical team. One problem that can be difficult to diagnose is the mismatched maximum transmission unit, or MTU. This is often called an MTU black hole. Different types of WAN connections have different MTU settings. That is, the largest allowable size of a packet that can traverse a link or be accepted by the link. The MTU for Ethernet, by the way, is 1500 bytes. Routers will negotiate the MTU between links using ICMP, that's Internet Control Message Protocol. If ICMP has been disabled on the router, which is a common practice, when a router receives a packet that exceeds the MTU, it will not respond and it will drop the packet. The sending router continues to send the oversized packets into the MTU black hole, never getting a response back that the packets are too big. So the data is flowing, but it's not going anywhere. When suspected, this too should be moved up the support chain to the correct technical team. NIC teaming can also create a problem. This is the process of bonding multiple network interface controllers on a single system for the purpose of increasing bandwidth or for failover purposes. A misconfiguration may actually cause a loss of performance or, in a worst case scenario, the total loss of functionality. If you're dealing with teamed NICs, move it up the support chain. Then there are power failure or power anomalies. Power failures are easy to diagnose but may be difficult to recover from. While battery backups and generators may mitigate the issue, they will not resolve the problem. If the problem occurs within the building, contact the appropriate group responsible for building maintenance. If the problem occurs outside the building, contact the appropriate utility. Electronic devices are sensitive to power issues. Anomalies in the quality of the electricity delivered to the device may cause problems. Using battery backups or uninterruptible power supplies with power conditioners will help to mitigate power anomalies. With problems to escalate covered, let's move on to problems that you can resolve. We will begin with incorrect IP configurations. Under incorrect IP configurations, we will begin with the default gateway. The default gateway is the local network or computer's access to outside networks. An incorrect gateway will keep traffic from reaching its destination. If it's suspected, verify what the correct gateway settings should be and correct it. Then there are duplicate IP addresses. When duplicate IP addresses have been configured, the first device booted up will get the address, and the second one that gets booted up will get an address supplied by a PIPA. This can occur when DHCP address reservations have not been configured correctly. This is easy to verify and correct and should be done when an PIPA address is received by a device. There are other DHCP misconfigurations that can occur. The problem is expressed in a similar manner as the duplicate IP address problem, as in a PIPA address is supplied, and is configured by caused by a misconfigured DHCP server. Again, verify your DHCP settings and correct. Then there are DNS misconfigurations. Users complain that they cannot get to resources or destinations on the network when using the host name. DNS is used to resolve host names to IP addresses, so a misconfiguration will prevent the function of the DNS process. Verify the correct DNS settings and correct as needed. It's also possible to have incorrect VLAN assignments or incorrect virtual local area network assignments. Users will complain that they cannot get to necessary network resources. This tends to be a single host issue or to involve a small group of hosts. Verify the VLAN settings and again, correct as necessary. Incorrect interface configurations will also create network issues. Users may complain of poor network performance or not being able to connect to resources at all. This issue tends to affect a whole network segment. Configuration issues could include mismatched port speeds and/or duplex settings on the interfaces. Verify the correct interface configurations and correct the settings. Simultaneous wireless and wired connections will also create some networking issues. Many laptops come with wireless and wired network capabilities built into them. It is possible for a laptop to attempt to use both at the same time. This may cause the device to quit communicating on the network as a whole. Reminding users to turn off wireless capabilities before joining the wired network will resolve this problem. Not having good end-to-end connectivity is another common problem. The complexity of networks will just about guarantee that end-to-end connectivity, the ability to reach remote hosts, will be lost at some point. The ping and tracer utilities can be used to find where the break in communication occurs. This information can then be used to determine the next course of action. Last up is hardware failure. Networking equipment and devices will fail. When this happens, it is usually denoted by the sudden loss or intermittent loss of networking functions or access. The key to resolving this issue is in determining what has failed and replacing it.